Hi folks, today I want to look at another paper by David Parnas, and this paper looks at the role of documentation in the design and implementation of complex systems, essentially at how the distribution of information affects the design of these systems. This paper came out in 1972, and that's the same year that Parnas published his other paper, which goes into the criteria using which one should decompose a system into modules. I have another video which looks at that paper in detail. Let's start by looking at what we mean when we talk about the structure of a system or the structure of a program. The author's definition is that structure is simply a partial description of a system. It divides the system into a set of modules, it gives some high-level description of each module, and then specifies some connections between the modules. The author leaves the definition of module imprecise, but it is the definition of connection that this paper dives deeper into. The standard definition of connection is some sort of where transfer of control happens, or parameters are passed from one module to another, or data is passed between modules, and so on. But the author claims that this is a dangerous simplification which can lead to trouble. Parnas's definition of a connection between systems is that connections between modules are the assumptions which modules make about each other. And this is the crucial point of this entire paper. If you want to remember one thing from this paper, remember this. Connections between modules are the assumptions which modules make about each other. And you can begin to understand the implications of that definition if you look at two common things that we want to do with our systems. We want to make changes to them, and we want to prove them correct. And in both those situations, it is the assumptions about other modules which either make proofs much harder or make changes to a system much harder. If we're changing a part of a system, we have to ask what other parts of the system is this change going to affect? Those are the assumptions that all those other parts of the system have made about this one module. Let's zoom into what goes into the order in which we make decisions when designing a system. Progress in design is marked by decisions, and these design decisions eliminate some possibilities from the overall design space. And the order of these decisions affects the structure of the final system. The author goes into three different things one could strive for when designing a system, and how those lead to different sequences in how design decisions are made. So the first one is we want to make the external characteristics of the system good. And the way we can do that is by deciding first what those external characteristics must be. This is the top-down or outside-in approach to design. Another goal could be completing the project as fast as possible. But if we want to speed up product development by dividing it into different modules where each module can be independently developed by separate teams, this encourages splitting the development along organizational lines. This is also known as Conway's Law, which says that the structure of your system ends up mirroring the structure of your organization. Another goal might be to build a system that is easily changed on an ongoing basis. This will require a very different strategy. Since later decisions depend on earlier decisions are much harder to change than later ones. This means that if we want a system that is easy to change, the early decisions should be the ones which are least likely to change. And looking at these three goals, each of these suggests a different ordering of design decisions, and they are in conflict with each other. The author talks about the importance of documenting these systems and how documentation should follow a standard organization and use a common vocabulary that is understandable by everyone in the organization. And before we go into how the flow of information affects design decisions, we have to talk about what makes a good programmer. Now, this section might be controversial, but let's just stay with what the author is saying here. Parnas claims that a good programmer makes use of all the information that they have. Now, I would quibble with this just a little bit. I'd say that a clever programmer makes use of all the information they have, and a good programmer makes use of all the relevant information that they have. What happens when a programmer uses all the information that they have? They end up depending on that information. And if that information has internal implementation details, then they will end up depending on internal implementation details. These are clever programs which cause trouble later. By using the information that we have, by using the information that the programmer has about other modules, they can drastically increase the connectivity of the system structure. And remember, we're defining connectivity as the assumptions that a module makes about other modules. So how do we get around this? The author argues that the way to solve this problem is by controlling how information about the modules is distributed to programmers. This information should not be accessible to everyone, but it should be controlled. And if we want programmers to not depend on internal implementation details, we should simply not document or publish or share those internal implementation details with the programmers. Essentially, what Parnas is arguing for here is the primacy of interfaces, that we should define interfaces between modules. These interfaces are the explicit designed dependencies that we want modules to export. And programmers should only depend on these interfaces and not the internal implementation details behind these interfaces. So, to conclude, the designer of a system has to explicitly take control of the distribution of information regarding that system, because it is this information that will then be used and depended upon by programmers writing programs against that system. It's very interesting to contrast what Parnas is saying in this paper with something called Hiram's law. This is an observation which says that when an API is used by a sufficient number of users, by a very large number of users, it doesn't matter what is promised in the contract of the API. All observable behaviors, even internal implementation details of this API, will end up being depended on by somebody. And this typically happens with very basic low-level APIs that are dependent upon by thousands or millions of programmers. And with that many use cases, every tiny internal implementation detail ends up escaping, so to speak, in terms of performance or behavior, and ends up being depended upon. So that was Parnas's paper on how we should control the flow of information in order to design better systems. I hope you enjoyed that, and I'll see you next time.